All right, y'all, so we're going to be going over 9.5, which deals with properties of logarithmic functions. All right, so there's 4 properties I'm going to list here, and these examples will go through using these properties. So the first one we got is what we call the product rule of logarithms. And remember, since logarithms are really exponents, these are going to mimic your exponent rules. So the product rule of logarithms says if I got the log of a product, I can rewrite that as a sum of the logs. So I could do log A of M plus log base A of N. So a product can be rewritten as a sum of logs. Also, a sum of logs can be written as a single log if I needed. So these will go both ways. Second one is called the power rule of logarithms. So this is when I got a base to a exponent. So if I got something like log base A of M to the P, then I would rewrite this as P times the log base A of M. So if we was looking at exponents and you had an exponent raised to an exponent, you would multiply them. So that's what this is doing. Log A of M would be an exponent, and you would be raising that to the exponent of P. So in the long run, you would multiply those. All right, next we got our quotient rule. Of logarithms. So the quotient rule deals with division. So if I got a log base A of M divided by N, this would follow the quotient rule of exponents, where we would subtract the bottom exponent from the top exponent. So that's what this is doing. You're taking the log base A of M on top minus the log base A of N. So it's always the top minus the bottom on that. All right, so the last property, and then we'll start working these, is what we call the log of a base to a power. So this would be log base A of A to the X. When this happens, when this log base matches the base of the result to an exponent, the answer will always be the exponent. So this one follows number 2, except for number 2, the base and the base of the result don't match. On number 4, the base of the log matches the base of the result, and anytime that happens, remember, log A of A equals 1. So when you bring that X down to multiply, you're basically multiplying the X times 1, which is why we get an X on that one. All right, so what we're going to do is just start working these examples, and they'll sort of go through all the rules here. So for the first few, they want us to express as a sum of logarithms. And the only one where you could express as a sum of logarithms is using this product rule. So they're going to give me a product, and I'm going to rewrite it as a sum on these. So the first one, I got a log base 22 of 22 times 484. Now, they don't want us to evaluate these. They just want me to rewrite this as a sum. And notice up here that the sum is rewritten using both of the factors. So I got two factors here. And you just got to make sure both of these are written with a log base 22. So I would get a log base 22 of 22 plus a log base 22 of 484. So I've rewritten my product as a sum. That's all you did to that one. So what I did, I sort of alternated using logs and natural logs on these. So this one has the ln, which is the natural log of b times c. So to rewrite that as a sum, I'll do the ln of b plus the ln of c. So these aren't too bad. They're just getting us ready for 9.6 when we start solving equations using logarithms. All right, so the next one wants me to express as a product. And one over here, let me turn back, that expresses anything as a product is the power rule. And all you're going to do is bring that exponent down and rewrite it as a product. So number 3, I got a log base 10 of x to the 15th. So power rule says that I want to bring that 15 down to the front and rewrite it as a product. So this will give me 15 times log base 10 of x. So basically, anytime we have exponents up here following a log, we're always going to bring those exponents down to the front and rewrite them as a product. All right, so number 4, I'm going to do this with an ln. ln of the 4th root of a 6. So anytime I give you a log or a natural log and it's got a radical in it, you got to first convert the radical. So I'm going to convert the radical to a fractional exponent. So first, let's convert that radical. So bring down that ln. Our base is 6, and radicals end up as a fractional exponent. So do y'all know what the exponent will be for that? All right, because y'all didn't have much practice doing these, but we did these the other day. So since the 6 don't have an exponent by it, I would make that a 1.
1.
So it's going to be a 1 over 4. There you go. So now I've got it written with the fractional exponent. Now we're going to write this as a product by moving that 1/4 to the front so that you get 1/4 times the ln of 6. So they're not too bad. Just remember to convert them radicals over, okay? All right, so we've written them as a sum. We've written them as a product. Next, we're going to express as a difference. So express as a difference of logarithms. So this will now be using my quotient rule. So for number 5, I got a log base t of d divided by 3. So you got to distribute the log t to both of these. If they're on top, they're going to be positive. If they're on bottom, they're going to be negative. So when I rewrite this, I'll have a log base t of d minus a log base t of 3. All right, then likewise, we'll do one with ln. ln of m divided by t. And I just wanted y'all to realize that these work the same way, whether they got a log or a ln, okay? So same thing here, I'm gonna distribute the ln to both of those. So I got a ln of m minus my ln of t. And y'all just remember, when you're writing these in here, that's a ln, not an in, okay? If you put in the ln, it'll make it bold so that you know you got the right thing in there, okay? All righty, so now that we've done those, they want us to rewrite as sums or differences of logarithms. So what that means, all rules are in play now. The product rule, the power rule, and the quotient rule. So I'm going to start out with the ln on this one. ln x to the 4th, y to the 6th, z. So the first thing we would do, since these are all being multiplied, we would rewrite these as a sum. So you got 3 factors, so you're going to have 3 terms. You're going to have an ln of x to the 4th plus an ln of y to the 6th plus a plus a ln of z. So we've rewritten it as our sums, so there'll be no differences on this because I didn't have no dividing going on. But there is one more thing I need to do to this.
Simplify it.
Yeah, I'm going to simplify it. And if you notice, the only thing I can do to simplify this is
Multiply.
is rewrite them as a multiplication. There you go. So all these exponents are going to have to be brought to the front and rewritten as a product. So ln of x to the 4 becomes 4 times the ln of x. And then you do that here. Ln of y to the 6 will become 6 times ln of y. And then the z didn't have an exponent, so that'll just stay the ln of z. So notice, when you're done, you cannot have exponents sitting behind your variables. They all got to be brought down to the front and written as these products, okay? Sort of fun doing math where you don't get no answers, you're just rewriting everything. All right, so let me turn out the big boy here. A log base b of p to the 4th, q to the 5th, all over m to the 3rd, b to the 9th. So let me tell you what I'm going to do to this. I'm going to distribute my log b to all 4 of these factors here. When I rewrite this, if they're on top, they'll be positive. The ones that are on bottom will be subtracted, so they'll be negative. So I'm going to rewrite this out now. So I got my log b of p to the fourth plus my log b of q to the fifth. Both those factors were on top, so they're both positive. The M3 and B9 are on bottom, so they're going to be negative. So minus log b of m to the third minus log b of b to the ninth. So when you rewrite these, tops are always positive, bottoms are always negative. All right, so let's see what we can do to this. Looks like we got a lot of exponents we're going to be bringing down. I'll bring down that exponent, the third exponent. But y'all, this last one, that log base b of b to the ninth, let me turn my paper over. That is going to follow property 4, which is the log of a base to a power. When my base of my log matches the base of my result to an exponent, the answer is always the exponent. So look what the base of my log matches the base of my result to an exponent. So that's just going to equal a minus 9 when we rewrite that. So let's see what we got. We're going to bring the 4 down. So that'll give you 4 log b of p. I'll bring the 5 down. That'll give me 5 log b of q. Minus, we'll bring the 3 down. That'll be 3 log b of m. Minus, we said that equaled 9. Because what would happen, if you bring the 9 down, the log base b of b turns into a 1, and 9 times 1 is still going to give me a 9 for that answer.
9.
So, y'all, when you get this final answer, you cannot have those exponents up by them variables no more, okay? They all got to be brought down. And then you got to simplify anything that we can, such as that log b to the ninth. All right, so any questions on that one? All right, so that's one of the trickier ones. Now, number 9, I did with LNs. I got an LN of 2 divided by 9x to the 9th y. So y'all want to try this one, or y'all want me to go?
You got it.
All right, so here's the thing. If they're on top, I'm going to keep them positive. And these 3 factors that are on the bottom will all be subtracted when I rewrite this, okay? So I'm going to do my ln of 2. Because 2 is the only thing on top. It's the only one going to be positive at this point. And then we'll do our ln. Well, I'll keep messing up my ln. ln of 9 minus the ln of x to the 9th minus the ln of y. So that's the ln right there. So next, what I would do to this, there's only one thing to do. I got an ln of 2, ln of 9, ln of x to the 9th, and the ln of y. The only one that I can do anything to is the one with the exponent of 9. That exponent of 9 has to be brought down and written as a product. So you got your ln of 2 minus your ln of 9 minus, oh, what's that going to give me? 9 ln x minus ln of y. So now notice I don't have any exponents left, so I'm happy. So that's the main thing you got to watch out for. If you put it in MATLAB at this point, it'll tell you you got the right answer, but it's not in the right form, okay? All right, y'all, log square root c to the 6 times a d. So the first thing I'm going to do is put this C6D in parentheses and figure out what to make that fractional exponent. So I will tell you the top number of the fractional exponent will be a 1. But there's not a number in that notch on this radical this time. So does anyone know what that number is? If you
It's a
just
1.
Oh, what did y'all just say? So let me ask you this. If you see one of those little radicals on a calculator, what's it taking?
The square root. It's
A
2,
square.
right?
No, that's a 2. There you go. So square roots are always written as a 1/2. Good job. Now, when we got stuff in parentheses followed by an exponent, we're going to multiply both of these by that exponent. So the d don't have an exponent, so remember, it's a 1. So we're going to take the c, 6 times 1/2. So that'll be what, 6/2, which will give me a 3. And then d, 1 times 1/2 is just 1/2. So that's the power rule of exponents. When you got an exponent raised to an exponent, you multiply those exponents, okay? All right, so we're finally written without this radical. So now we'll rewrite this product as a sum. So I'll do my log of c to the 3rd plus my log d to the 1/2. All right, last move. And usually this will always be the last move, and it's to bring them exponents down. So this one gives me 3 times log c plus this one will give me a 1/2 times log d. So y'all just remember when you rewrite these, I treated this like it was all in parentheses, okay? And then let's see, no more exponents are sitting up, so we're happy. All right, so this is the last one doing this type problem, and then we switch over and rewrite them as single logs. So this is
Mr. Rathod, on number 10, that D, is it a base or is it just a regular D?
it's just a oh, I see what you're saying. It's the regular D.
Okay.
So these, since they don't have logs bases on them, these would both be basically a log 10 on those.
Okay.
Okay. Oh, y'all, watch this big one here. This is a log base C. And this one has big parentheses with a big radical. My radical is a 4th root. And I got a M8 N20 over C7 A5. So the first part of this problem is going to be what we did over here, getting rid of that radical. So we're going to rewrite this. So I'm going to take my M8 N20, put that over my C7 A5. So I need an exponent for that radical. What y'all putting on this one?
One divided by 4.
There you go. 1/4. All right, now notice up here, I distributed that exponent to everything inside. You're going to now distribute the 1/4 and multiply by every exponent in there. So let's see what happens. 8 times 1/4. So 8 times 1/4 will give me 8 over 4, which is 2. So the m now has a 2. N had a 20. So let's see, 20 times 1/4 is 20 over 4, which will give us a 5. Then I got a 7 times 1/4. Well, that's just going to stay, what, a 7 over 4. So that don't simplify. So C becomes a 7 over 4. And then the A had a 5. And 5 times 1/4 gives me a 5/4. So all we did was convert it out of that radical into a fractional exponent, and then we distributed that times all the exponents inside the parentheses. Now we're actually going to rewrite this as sums and differences. If they're on top, they're going to be positive. If they're on bottom, they're going to be negative. So y'all, here we go. Log C of m squared plus log C of n to the 5th. So both of them are on top and positive. Now we'll subtract both of those on the bottom. So log C of C to the 7/4 minus log C of A to the 5/4. So let's see what we got going on. Looks like this one, the exponent's going to come down to the front. Second one, exponent's going to come down to the front. I'm going to skip that one. The last one, exponent's going to come down to the front. Now the reason I skipped this one, because that log base C matches the base of the result to an exponent. So the answer for this whole term will be 7/4. Okay? When the base matches the base of the result to an exponent, the answer is always the exponent. So y'all, let's see what we got. This one will give me 2 times log C of m, plus I get a 5 log C of n, minus, this one is just going to be 7/4, minus, that one I'll bring down to 5/4 times the log C of A. So let's see, we don't have any more exponents to worry about, and we evaluated that third term, so we are finally done. So convert that radical, distribute the exponent, rewrite that as sums and differences, and then take care of the exponents, and then that property of the log of a base to a power, okay? Whoa, that's a good one though. You can get through that and pretty good. You got an understanding on these, okay? So, any questions on that before we go the other way?
No.
Y'all, these aren't too bad. You just got to follow them 4 rules you got there, okay? So now we're going to go the other way and rewrite sums and differences as a single logarithm. So express as a single logarithm. So this one has a log base C of 67 plus a log base C of 59. So I'll probably have to break out the calculator for that. All right, so we would rewrite this as a log base C. Since they're being added, we would rewrite it as multiplication. 67 times 59. And then MathLab makes you go on and actually multiply that out. So let's see what is 67 times, what's that, 59. So that'll give me a log base C of 3,953. So that one, rewrite it as a product, but then multiply that and get me the final answer. 13 is a log 100 minus a log of 10. So these ones are subtracted. So to rewrite subtraction, it's going to look like division. So since 100 is the positive term, it's going to the top. The 10 is the negative term, it's going to the bottom. Hey, but y'all, we can do that. We know what 100 divided by 10, that's just going to give me a log of 10. So here's a question. They want that answer first, and then it says this simplifies further to get, well, what is a log base 10 of 10 give me? What exponent would you raise that 10 to turn it into a 10? And y'all got this powerful calculator here. Any log can be done on the front because that's a log base 10. So just put in a log of 10 and see what you get. So let's see, log of 10, I get 1. So that one simplifies to give me a 1. So y'all watch out on those. Some of those, especially on 13, when you put that answer in, it wants you to simplify it to the final answer that you get, okay? Anytime that log base matches that result, the answer is 1. All righty, so this is like your number 14 you were asking me about. And the trick on this one is not working it, it's actually putting it in the MathLab.
Right.
All right, then that's a 5 log C of y minus 4 log C of x. All righty, so since I'm going the other way, the first thing I would do to this one is bring these exponents up behind their variables. So the last thing you did, writing them as sums or differences, it's the first thing you do going the other way. So this would become a log base C of x to the 1/3, plus this one would become a log base C of y to the 5th, minus my last one, which is a log base C of x to the 4th. Now remember, if they're positive when I rewrite them, they'll be on top. If they're negative, they'll be on the bottom. So we're going to break out this log base C. On top of my fraction, I got an x to the 1/3, a y to the 5th, all over x to the 4th. So I will say this. I would be done if these x's didn't match up. If that was like an x, y, and z, I'd be done. But I cannot have x's on top of a fraction and x's on bottom of a fraction because they don't consider that simplified. So what's going to happen? You got an x to the 1/3 on top, x to the 4th on bottom. The larger exponent is the 4. So you take the exponent that's larger and subtract the smaller exponent from it. So 4 minus 1/3. So I'm going to turn that back into a fraction, and I'm going to get 11/3. Now, the x has to stay in the bottom because that's where the bigger exponent was. So the x in the bottom has an exponent now of 11/3, and the only thing on top now will be the y to the 5th. So, y'all, when you got variables over the same variable, you're subtracting exponents, and you're always going to subtract the smaller exponent from the larger, and then the variable will stay where the larger exponent was. Okay? So this answer is tricky. I'll actually do it after I do my lecture, but what I would do on this, I would get the log and do the subscript for the C. Then I would hit the fraction bar so that it would put me a big fraction there. On top, I would put in my y with an exponent 5. On bottom, I would hit my x and then grab its exponent by hitting the exponent bar. But then when you hit that exponent bar, you got to make it a fraction. And then you'll put in your 11/3. So I'll show you that one after I get done with this lecture, okay?
Okay.
Because there's so many fractions on that one, it's tricky putting it in. Oh, y'all, let's see what we got here. This one's an ln. ln x to the 6th minus 3 ln cube root of x to the 5th. All right, so the first thing we're going to do is rewrite this without the radical. So bring down your ln x to the 6th minus 3 ln x with a fractional exponent now. So the cube root of x to the 5th written as a exponent would give me x to the 5/3. So remember, the exponent is always on top. The index or root of the radical is always on the bottom. So now what I would do is move this 3 up. So I got a ln x to the 6th minus, now since we're pulling that 3 up, it's going to multiply by the 5/3 that's already there. So let's see what that'll give me. That'll give me 15/3, which equals 5. So this is now going to be a ln x to the 5th. So notice, we really haven't rewrote it yet. We've just taken care of that exponent at the moment. Since these are being subtracted, it's going to look like division. X to the 6th is positive, it goes to the top. X to the 5th is negative, it goes to the bottom. If y'all remember, I cannot have x's over x's. So you got an x to the 6th on top.
So it's a 1.
And that's just going to be an x to the 1. And there you go. So that didn't end up being bad. That number 14, the reason it's sort of tricky is just getting that answer into the math lab, I think. All righty, let's see. Now the last two, we're going to test your factoring ability. So I got an ln of x squared plus 10x plus 24 minus ln x plus 6. All right, so nothing I can do to these other than rewrite them, and since they're being subtracted, they're going to look like division. So ln, the top will be the x squared plus 10x plus 24 And then the bottom will be, what, I got an x plus 6?
Mm-hmm.
So here's the trick on this one. We've got our answer, but we're not what we would consider in simplified form. To be in simplified form, we got to make sure there's no factors on top that match that factor on the bottom, which means what we're going to have to do is factor the top.
Mm-hmm.
All right, so let's see what y'all do. We got an x squared, so that's an x and an x. That 24 is positive, so both of these will be positive like the 10.
Mm-hmm.
Give me factors of 24 that add to get a 10.
6 and
6
4.
and 4.
There you go. Which means I do have a factor on top that matches the factor on bottom. So we're going to cancel out that common factor, basically making it a 1. So that my final answer is going to be the ln x plus 4. Now let me tell you, you got to keep the x plus 4 in parentheses so that the ln knows it affects everything, okay? So that one actually has to be kept in parentheses. So basically, it's just, you know, they always got to check your factoring on these problems.
Mm-hmm.
Oh, what's that, an x squared? Now, y'all know you can, if you're weak at factoring, you know I got a factor program in here. So let me go like 16, say you're weak at factoring, hit program, go to the one that actually says factor and hit enter on it twice. And then you punch the numbers in like you did the quad. So that would have been a 1 enter, 10 enter, 24. And when I do that, it gives me my x plus 6, x plus 4. Okay? So notice, this is going to be sort of similar. So I'm going to take my log. This one's positive, so it's going on the top. And then the x squared minus 4 was negative, so it's going to the bottom. Now, y'all, I will say this. Both of these will factor. So I'm going to have an x in front of every one of my parentheses. And I can tell you the signs on top will be unlike. The signs on bottom will be unlike. And that's because these last numbers are negative. Now, on the top one, you want factors of 14 that equal 5. So remember, if you're weak at factoring, just hit your calculator. That's a 1, negative 5.
9 and 5.
Oh, you're close.
9.
Oh, you're so close, but not a 9.
Negative 4.
So it is a positive 2 and a negative 7. Because C14 only had 2 ways to get it, right? 1 and 14 and the 2 and 7. And the ones that gave me the 5 were my 2 and 7. Now look at this one. You got a 4 at the end. There's no X in the middle. So that would be a 0 for the B. So on this one, you would put in a 1, 0, negative 4. But here's the trick. There's only 2 ways to get a 4. 1 times 4, 2 times 2. Only one of these will give me a 0 like the middle. And that's if both of them are 2s, right?
Plus 2 and negative.
And just remember, this is called the difference of perfect squares. So basically, the front is the square root of the x squared, and the back is the square root of the 4. But can I do anything with that? What y'all doing to this problem right here?
Oh, I'm looking. You are.
I hope you're doing like I did to these ones.
Yeah, we can cancel it.
Yeah, we're going to cancel them x plus 2s, right? Now, I will say on this one, since it ended up as a fraction still, you can put x minus 7 over x minus 2, and you don't have to put them in parentheses because it knows this whole fraction is being affected by the log. The reason I had to keep this one in parentheses because if you didn't use parentheses, it would do a ln of x, then plus 4. It wouldn't do the ln of the x plus 4, okay? All righty, so let me see. I'm going to try to pull up that homework real quick. So it might take me a second getting it pulled up.
Okay.
And y'all, these are just getting us ready for those equations we got coming up in the next class. Because to solve exponential, we rewrite them as logarithmic, and to solve logarithmic, most of the time, I rewrite them as exponential. Right, I'm getting there. I've almost made it to Blackboard. So y'all, my plan is we'll knock out 9.5 and 9.6 this week. Y'all gonna have Thanksgiving. When we come back from Thanksgiving, we'll do 9.7 and get y'all ready for that last test. And then the rest of the year, I'm just gonna be studying for the final. So y'all's final will be due by December 15th, I think it is.
Are we gonna have bonus questions with this fourth test?
Yeah, I'll probably get them ready and send them out probably by Friday of this week.
Okay.
And that way y'all have something to play with over the Thanksgiving break.
Well, thank you.
All right, so am I going to your specific problem or am I just doing one generic? Let me just pull yours up.
Okay. I wrote it down.
Oh, that's the only one you got on there too. You got
Yeah,
that?
I was just having a hard time entering it. I don't know how to put it in MathLabs. It's tricky.
Uh-huh. So let me go up here so I can share this now with y'all. All right, so I'm gonna click on your number 14 here. Y'all seeing her screen? All right, so it's trying to pull up the problem. You're seeing a blank screen right now though, right?
Mm-hmm.
All right, so here it comes. It looks like it's about to pull it up. Ooh, my internet must be the slow one over here. All righty, so let me just write this real
I
quick.
got the
Okay, so what was your answer? You should have a log base b of y to the third on top.
no.
And then looks like you should have, so that was 4 minus a half.
My answer is, hold on, I'm just trying to make sure I got the right one before I tell you to put in the wrong answer.
So it looks like you should have got a log base b.
Yeah, with my y to the third.
And then your x on the bottom had what exponent?
X3.
Oh, I was getting X7 halves on that. Let's see what
That's
happened.
what I got. I got X7 halves minus X negative 7 halves and X to the third as my exponent.
Oh, so we don't like them exponents being negative, so that's why the X has to be on the bottom. So let me show you how your answer should look real quick.
Okay.
So I want to share my screen where I wrote that real quick. So do you see how I got it? Log B to Y3 over to X to the 7 halves. So they don't like it when y'all have these negative exponents and stuff. Exponents always have to be written positive in your final answers. So we're going to write it like this. So let's go back to your problem and let's see if you can actually put this in for us.
Because I got that answer.
So the first thing you do, write log. Are you on the homework?
No, I'm writing it down on my hand.
Okay, I don't think it'll let me write for you on this. Oh, it's letting me write it. So you see how I got log in there? Then we would hit the subscript, this one with the little box to the right and below.
Okay.
And then I would put in your C, what's your base, a B?
Yeah.
Now, I'm going to arrow out of that. Now I need to hit the fraction bar. On top, you got a Y to the third. So we would put our Y and then come down here and click the exponent and put in the 3 for that. Then let's go down to the bottom, put in our X and grab its exponent. But remember, its exponent is a fraction, so I'm going to hit the fraction bar now. And what did we say we had? 7
over 2.
So now that we got it in like that, it should take that when I don't know if it'll let me do it. Said I submitted it. So let's do this.
It said it was wrong.
Oh, it's because I'm
Oh,
playing
that's
with
right.
it. Right now, you should have a green check on it now.
I
Refresh.
did. Now you can leave it.
But girl, that's a really tricky one there to put in because all these fractions and stuff.
I know.
But that's
I
it.
played with it all weekend. Thank you. I played with it all weekend.
Yeah, and that's the thing on that is putting these answers in MATLAB sometimes is harder than actually working them.
Mhm.
All righty, so let's see. It's a mild day today. That's it. So,
It shows that my homework is late.
hey, check this out. Everybody's 9.5 is going to show like it's late. But it's not penalizing y'all or anything, so just work it.
Okay.
It'll let y'all work them without penalty. I didn't want to push this last week too much, so I just slid that one to this week, which means probably, I can't remember if I had 9/7 set for this week or not, but even if it shows it's due, don't worry about it. We're going to knock it out after the break.
Okay.
Okay.
All right.
So y'all practice those, and then next class we'll be solving equations with them, okay?
All right. So we'll see you Thursday.
Yeah, Thursday for sure. And I'll send this
All right.
out later on today for you.
All right. Thank you. Have a good day.
All right. Y'all have a good day.
You too. Thanks.